In this video, I'm going to apply the process to solve a LeetCode medium question for the binary tree. The problem asks us to find the node can be seen if a person standing on the right side of the tree. As an example, one case, it would be 1, 3, 4, which is top to bottom. And first, let's think about what we need and construct our recursion function. So, of course, we need a tree node, and we need this int array to store the right side most value. And besides that, since we want to store it in order from top to bottom, we also need additional variable height. And to do so, we simply create a new function that has the variable we wanted, and at this function we can just call it. And how do we approach this problem? Let's do the easiest task. Yes, that's the base case. When shall we stop our recursion? And it's actually very common for the tree type question. We always stop when the node is null, which means that it's a dead end. We shall stop. Then we need to think about what we need to return. In this problem, what we do is to store the rightmost node into an array, which essentially is printed to a chunk of memory shared by our recursive function. Although we aren't returning anything, we are actually returning by updating the array. However, we don't need the result from recursion in this problem. We don't need it because think as if we are in this node. Our recursion to do is to resolve the level below this node, and that to do nothing with my current level. We shall now think how do we simplify the task. We do a simple thing, which is determine if the current node is on the rightmost node. If so, I store it. If not, I ignore it. Either way, I shall pass control to my recursive call to handle the rest of level. Binary trees recursion also involve on the order of visiting. We got in order, pre-order, and post-order. For this problem, I choose in order and first visited on the right side of tree, because in this way, I'm able to visit the right side deepest node first. Does it matter? It does. It can guarantee that I always visiting the rightmost node first on the same level. We shall do a proof here. Suppose that there is a tree and with two nodes at same level, and we want to show the right one always visited before the left one. And here I prepare a simple cases. And for example, I want to show that 9 always visited before 3. What we do is to find the lowest common ancestor, which is 1. And by the in-order property, all the nodes on the right-hand side of 1 always visited before 1. And of course, always visited before the left node of 1. And our proof is complete. And lastly, we want to resolve the recursive body. As we've discussed it before, the first node we visited in this level is always the rightmost node. So what we can do is to check if this is the first node we visited. If so, we store it. If not, we ignore it.